If I look tired in this video, it's because I fucking am. I had to prepare like 4 fucking seminars in 2 days explaining the entire fucking universe. So yeah, let's roll the intro. When we're talking about something out there in the real world, something that just is and does not change with your thoughts, we should treat it as such. Nature doesn't give a damn about our ideas, beliefs, dreams, and wishes. She just is. And we should always keep that in mind when discussing something real, something that's out there, tangible, and measurable. People often go into heated debates over some scientific topics, and it gives me headaches. Why? For several reasons. First of all, no matter how much we wish that we were all equal and that everyone's opinion has some value, that's simply not true. Someone that actually took the time to study a problem in great detail can bring much more value into the conversation than someone who just knows a thing or two, right? For example, people love to talk about theoretical physics, string theory, black holes, relativity, particles, and stuff, especially when some new movie comes out like Gravity or, I don't know, Interstellar. That's perfectly fine, but you can't just watch some PBS Nova or Through the Wormhole or Cosmos by Carl Sagan or Neil deGrasse Tyson and think that you actually understand those things enough to yell nonsense at physicists, which is what some people love to do apparently. The Earth is flat. You can't prove that it's a round object. We've been lied to. We have chips in our brains planted in by the government. Some people say that. When you try to explain things to them, they will always find an excuse. They will always find a loophole and tell you that you're just a brainwashed sheep. Wake up, sheeplings. That buys into everything that government says. The government is always the main villain. They will even go as far as to claim that gravity doesn't exist and use some extremely childish, uneducated arguments to try to prove you wrong. They will fail, of course, but in their eyes, they win and they just get more confident of their false ideas, unfortunately. You see, the thing is, physics is difficult and it requires a great deal of mathematics. Yes, we can use words to describe stuff when we're talking about something. Yes, we can discuss things on a conceptual level. But you have to keep in mind that those things are extremely... My friend used an expensive 3D printer to print this out, yeah. As I was saying, you have to be aware of the fact that words are extremely superficial. every concept in physics, every word that we use is only a label tied to a mathematical object. It's always like that. If you don't understand the very basics, like calculus, don't expect to be taken too seriously. Don't get me wrong. I don't think there's anything wrong with not knowing. But be humble. If you don't know something, research it, learn it, ask someone. In reality, unfortunately, most people can never hope to understand things like string theory. Not because they're stupid, but because the mere foundations on which that knowledge is built takes years to learn it properly. So let's assume that you're not a physicist or a mathematician and you're watching a TV documentary or some videos on YouTube, and there's Edward Witten and he says,
in string theory, a little elementary particle is replaced by a small vibrating string. It can vibrate in many ways, just like a piano string vibrates in many ways, giving us middle C and its higher overtones. So one of these strings can vibrate in different ways, giving us electrons, muons, and other elementary particles.
or Michio Kaku, and he says,
String theory takes you before the Big Bang, before Genesis itself. And what does string theory say? It says that there is a multiverse of universes.
or for example, Brian Greene, and he says,
You take a Lagrangian that can describe the motion of a one-dimensional entity through space-time. And you take that two-dimensional Lagrangian, and within it there's a field, X, that maps the world sheet of the string into the ambient space-time. And the action that describes this motion is basically the area of the world sheet using the pullback metric from the ambient space-time to the world sheet of the string. And then by using, of course, the standard sum over paths approach to quantum mechanics developed by Richard Feynman, we can work out correlation functions in this two-dimensional field theory, and those in principle would be the observables that describe the scattering amplitudes of strings in string theory. How's that?
and you think, this is all bollocks. They're out of touch with reality. What the fuck is this? How can they even know things like extra dimensions exist? What is this nonsense about tiny vibrating strings and black holes? What the fuck?
Water, fire, air, and dirt. Fucking magnets, how do they work? And I don't wanna talk to a scientist. Y'all motherfuckers lying and getting me pissed.
And then, maybe you're ambitious. And maybe you decide to figure it out. So, you go out to find a book about string theory. And you find one. This. A first course in string theory. And you look around the book and you can't understand a single thing. Because you don't understand particle physics. And also, you don't understand general relativity. That is, the theory of gravity. Here's this book. Yes, gravity can be really complicated. It's not that simple. So, you want to understand gravity. And you go out, you read that book. It's too complicated. You get another one to learn the conceptual basics. But then you realize that you don't know special relativity, So you get a book about special relativity, you study special relativity, and then you go back to general relativity, but you see that you have to understand some complicated mathematical methods like tensor analysis on manifolds, and to understand that you need to understand calculus on manifolds. To understand manifolds you need to understand topology. To understand topology completely you also need to know a bit of algebraic topology, that is combinatorial topology, and of course you should know some discrete mathematics if you really want to understand that stuff. Whew. Okay, now maybe you understand general relativity, but to understand string theory you also have to understand quantum field theory. So you get a book about quantum field theory, and you study quantum field theory, and you see that you don't understand it because you have to understand quantum mechanics first. So you get this book, you try to understand quantum mechanics, but it's too complicated. You need an easier book. You get this one, you try to understand quantum mechanics, but it's too complicated. You need an easier book. You get this one to learn quantum mechanics, but it's too complicated. You need an easier book. Then you get this Feynman's book, but it's too complicated. And you want to understand quantum mechanics. You need an easier book. And so you find this little book, for example, and somehow you go back up and you learn quantum mechanics. Then you go back and incorporate your knowledge into quantum field theory, but you need to understand it conceptually, so you get another book to understand quantum field theory on a conceptual level. But hey, you don't even understand classical field theory. So you get a book to study classical field theory. What are classical field theories? You need an example. You need to understand electrodynamics, which is a classical field theory. This is not so easy. So maybe you go to Feynman to learn some electromagnetism first. Okay, so you understand electromagnetism, and you have now some ideas about classical field theory, but no, you don't. You don't even know classical mechanics. So you get this book to understand the mathematical methods of classical mechanics, but it's too complicated and you need a simpler book. You get this one and you study classical mechanics in depth from here, but it's also too complicated. You need another book, so you study more classical mechanics. And maybe you go to Feynman again to understand the basics of classical mechanics. And you also see that there are things there like radiation and heat, thermodynamics, statistical mechanics. So you have to understand statistical physics to understand thermodynamics, heat. But to understand statistical mechanics, you need to understand probability theory and statistics. Is that all? No. There are also some things that you have to understand no matter what kind of physics you're dealing with. You have to understand partial differential equations. You really have to understand partial differential equations and all sorts of different mathematical methods. So, you've seen this pile of books. And what about it? Well, when you learn all this, along with some other stuff, because I don't have all the books with me right now, only when you learn all this can you even begin to hope to understand a fraction of what those string theory guys are really saying. You still won't understand string theory on a deep level, and you'll still have a lot to learn about nature. I'll include a hilarious comic about all this and a couple of useful links, so be sure to check that out in the description. It's hard to vape when it's not turned on. There we go. I'm an idiot. Here we go. So, by the way, I'll make an educational channel very soon, and I'll actually teach you guys everything that's in these books. Seriously. It might take me a couple of decades to go through everything, but hey, one step at a time, right? So stay tuned and subscribe if you haven't already done that. What was the point of my demonstration with books? You see, I'm not a genius, far from it. I'm just a theoretical physicist, an ordinary theoretical physicist, and we all had to go through all these books. We all had to spend hours upon hours drinking liters upon liters of coffee to understand this stuff. And that's just string theory. There's much more to physics. So please keep that in mind when you're arguing with someone that knows much more than you do about some of these things. Those people are not worth more than you. They're just human. And they're complete idiots on some other topics. For example, I don't know jack shit about law and legal stuff. I don't even know much about some other areas of physics, such as experimental physics or condensed matter physics. I mean, since it is physics, I do know more than a layman does. But when I'm discussing something with fellow experimental physicists, for example, I feel like a baby, like a chimpanzee trying to understand how a rocket works. It's just not my field of expertise. You know, when I go into the lab, everything breaks down and I'm like, did I do that? You know. What I'm trying to say is, we should respect someone's expertise. Not because they have a fancy academic degree, they don't have to. Not because someone says so. But because we should acknowledge the amount of work that went into learning all this stuff. And it's particularly dangerous when you know enough of some topic so that it makes you feel smart and knowledgeable, but you really aren't. SMBC comics call it Mount Stupid. As you can see from this diagram, it's epic. Of course, we should avoid appealing to authority, and we should stay skeptical. But we ought to be careful not to bash something or someone purely because of our own ignorance. The sad thing is, humans are just human, and yodels are just yodels. And we tend to act like dickheads sometimes. So, if you're an expert at something, you too should acknowledge the amount of work that you had to do to become one. Do not belittle the curiosity of the layman. Instead, show them the right way. Encourage them to understand more, even if only on a superficial level. And most importantly of all, do not abuse your authority. Too many scientists with fancy academic degrees use their authority, which comes from being an expert on some topic, to spread their agenda about some things they're not even qualified to talk about in the first place. That's just irresponsible, and if you're doing that, you're a pathetic piece of shit and a sorry excuse for a human being, let alone a scientist. I see this very often when it comes to climate change, controversy, or vaccination. There's always some douchebag McKnow-it-all PhD who spreads nonsense through media, and they don't even have the proper education. And they always talk about consensus, majorities, minorities, and all that nonsense. They even bring politics into it, and suddenly purely scientific questions become a partisan issue, and everyone has a strong opinion about it. That's nonsense. There's no such thing as democracy in science. Nature doesn't care about that. She won't change herself just because a majority stands for something which is inaccurate. She doesn't listen to polls, and she doesn't give a flying fuck about any consensus. She'll continue to do her thing, walking as she has always walked, with no concern whatsoever about what we think, believe, or stand for. To wrap this part up, let me read you a proverb, which you probably heard somewhere before, but for those who don't know it, here it is. He who knows not, and knows that he knows not, is a fool. Shun him. He who knows not, and knows that he knows not, is a child. Teach him. He who knows, and knows not that he knows, is asleep. Wake him. He who knows and knows that he knows is a wise man. Follow him. I mentioned vaccination and climate change, so I want to go back to it and say a couple of words about that, if you're wondering where I stand on those issues. I studied human biology and medicine for a couple of years before going into physics, and I know enough about it to understand the basics of how vaccination should work. I'm not an expert on this topic, but I'm always happy to read and learn more about it. But from everything I've seen so far, it seems to me that the anti-vaccination folks are paranoid and out of touch with reality. In practice, I won't avoid vaccination. I am vaccinated, and I wouldn't recommend anyone to avoid vaccination like the plague, like some people do. I think it's a safe bet, because we know how nasty some of these diseases can be. That's the only reasonable thing you can do when you're not an expert. And you have to make a choice. You take everything you know into consideration, you weigh the probabilities in your head, and do the right thing. So, what about climate change? Again, I'm not an expert in environmental physics, but I have some colleagues that are. Although, as a physicist, I'm much more qualified to talk about these things because I have all the necessary background knowledge to study environmental science. It's just not my specialization. From what I've seen, I would bet my own life, if I had to, that climate change is indeed real and human made. The evidence to me just seems overwhelming. I'll include some stuff in the description if you're interested. The thing is, a lot of scientists that go out into the media to spread their agenda about climate change aren't even environmental scientists. And it's even more ridiculous when some journalists, like some from rebel media, embarrass themselves by passionately defending climate change deniers. Look, the environment doesn't give a fuck whether you're a conservative or a liberal. It does not give a fuck about whether you believe that there's a globalist conspiracy or not. It is what it is, and I think it's extremely dangerous to let our emotions run wildly, blurring the line between facts and opinion. Even if there is a globalist conspiracy with an agenda, and there probably is in one form or another, it does not change the facts of reality. And isn't it a bit suspicious that so many climate change deniers come from the United States, the country that's only second to China when it comes to polluting the environment? The climate change regulations would hurt the US economy, so it is only understandable that there are some people who want to oppose environmental taxes and other regulations. Keep that in mind. Almost all scientists from all over the world have come to the same conclusion. Climate change is real and it is human-made. And they have every right to be mad about climate deniers. Because we're all swimming in the same pool, and the US and China are those fat kids that piss in the pool because they don't feel like climbing out of the pool to do their work. Many debates revolve around predictions and environmental models. The thing is, those are sophisticated mathematical models based on physical assumptions. And to make predictions, they need input data from measurements. But that's not as easy as it sounds. Our planet is a complicated physical system. You can't make a model which includes every single molecule, every breeze, every drop of rain, and every fart that propagates through the atmosphere. As usual, us physicists have to make approximations, and we have to introduce some reasonable assumptions about the system into our model. The sheer complexity of the system makes it difficult to choose the best set of approximations and assumptions in order to make a model with the best predictive power. Some of those models have failed miserably, but we're learning. There are newer models, and scientists all around the globe are working on refining those theories. But there's another problem. Every model needs some input to make predictions, and we can never measure everything to arbitrary accuracy. We can only make measurements for a particular model. We can make enough measurements for that model to do its thing properly, which isn't easy. Nevertheless, predictions aside, historical records seem to be pretty clear, and everything seems to be pointing at the same conclusion. Climate change is real, and it is human-made. As I said, although I am a physicist, this really isn't my area of expertise. It isn't my specialization. I'm a mathematical physicist, I'm a theoretical physicist. But I believe in this case, it is more reasonable to err on the side of caution. Don't you think? I hope I'm wrong. And I hope the climate denial folks are right. But until there's enough evidence to convince you, please don't do anything rash simply because it is in alignment with your political views. Be skeptical of all media, fake or not fake, mainstream or alternative. Be skeptical of scientists that go out into public to share their opinions. Hell, be skeptical of me. You're smart enough. Don't let anyone fool you, my comrades. Alright, that's it from me. If you enjoyed the video, give it a thumbs up and share it. And if you hated it, give it a thumbs down and share it so more people can hate it. And if you're here for the first time, please subscribe. And if you're already subscribed, check that bell near the subscription button to make sure that you're getting all the notifications. One more thing. If you're using AdBlock, consider whitelisting my channel. It really does make a difference. And before I go, let me present you The Wall of Comrades. Jerry Bowen was kind enough to support me on Patreon, and Beth was crazy enough to tip me on PayPal 2 times. For a limited period of time, anyone that's generous enough to support my channel either through Patreon or PayPal will have the opportunity to get their name up on this glorious wall. Gold letters are for patrons and silver letters are for PayPal buddies. Also, if you're a YouTube creator, I'll even include a YouTube icon next to your name. Even a single dollar counts, Patreon or PayPal. How's that for a cheap promotion? I do this because your support really helps me. So if you do want to help me, earn your place on the Wall of Comrades. Anyway, see you next Friday. I'm the Squatting Erudite, and have an above average day. Thank you for watching. Now you can see me 1,000,000 times. Cameras.
America, America. We're all